So this is the recording for the OmegaRace. There's another recording, if you haven't looked at it yet, that is me actually on my phone recording the game running on my laptop and my desktop to show that the networking part actually works. It's a lot easier for me to show code though. It's filming my desktop, so I'm going to do that on here. I have two instances of Visual Studios running on my computer right now, so that if I want to run it, obviously I need to connect to something else, and I can do that by having both running on the same computer. So, like I showed before, how mine works is when you start it up, it will look for a server, and then if it doesn't find one, it'll set itself up as a server, and then when another one boots up, what it does is it will find that server and connect. So obviously this one will connect. This one is now the client, this is a server. If you hit spacebar in both of them, then it'll boot up and it will connect them together. So how that works is basically when the game boots up, I have a network manager, and the network manager, when it's created, creates a client, calls connecting that client, and if it connected to something, then it's fine, and it just leaves it as a client and sets the network to a client, and if not, then it swaps it to a server. Basically, I have two different states that the network can be in. It can be rather a client state, or it can be in a server state. If it's in the server state, then it does some specific things differently than the client, but not too much. But I made them different sets just because it's easier visually to look at and to understand. So from the beginning, obviously we have the game. Where this happens is so in the network manager, I call instance, which just sets up if it should be a server or a client even before the main menu pops up, which makes it nice and easy. Then when you get into update, so I separated a couple things here. So first we have our input manager update, and then our game manager input update. So basically this just updates the input and then updates the input, so it'll create any packages that need to be sent into the output queue so they can be ready to be sent for anything for moving a ship or shooting a missile or laying a mine. Then I'm going to call the network manager and tell it to read out all of that. So it's going to take everything in the output queue and send it or loop it back. Then the game manager will take everything that's in the input queue and it'll execute on what's on there. So it has all these packages. It will create those packages and then execute on those packages. Then I call the network manager and tell it to do the physics update. So the reason why the network manager has control over this is because if you go into the physics update here, obviously I have a network manager because there can only be one network, so it's just a singleton that keeps track of the one network that's allowed. And then if you go into the physics update here, it's just a virtual function in my network class. So if you're a client, obviously this physics update does nothing because there is no physics update in the client because the client doesn't do any physics. But if you're on the server, then the physics update calls the game manager and tells it the update the game object's physics update, and then it also tells the physics world to update. So basically what the game manager game object physics update is I separated all of the game objects into an update and a physics update. This is because a lot of the game objects have like movement and stuff like that, or pushing stuff from the physics object into the object, which doesn't need to be done on the client. So I separated those updates, so on the server it will call those updates and it will go through all of that, but then on the client all it will do is just call the normal update and all the stuff that doesn't need to be called. So for example, in the physics update it's going to go through the ship, and on the ship the update does nothing, but on the physics update it says if it's respawning, does all the physics stuff, sets the position, all the stuff it's doing before, and then it also sets the object's new location, creates a packet and sends it to the network manager to be sent out when the next out push is called. So then in here it's going to then read all that out, which means it's going to loop it back, send it to the client if it needs to be sent. Then the game object update will be called, so things like the mine, which has a timer and things like that that need to be like the states that need to be checked in every update will go through even on the client, and then it will read out any more information that needs to be sent out. Then it will once again execute on anything on the input, then we'll call cleanup, and then the timing thing, and it'll do it all again. So the big thing here is I have a network manager. The network manager is just a singleton that keeps track of the one network that's allowed. The one network obviously can be client or server. So when you boot it up, it'll figure out if it needs to be client or server. And then it has like physics update, read in, execute on, read out, move all the different packages that can be called. So basically you call the network manager to say, hey, I want this package made and I want this to be sent, and then I want this package, or I need this kind of update to be called. I want it to connect to something. I want to swap between the two different things, like server to client, client to server, and then there's obviously cleanup. I want to clean up whatever kind of network's available. So this just keeps it so from anywhere you can just tell the network I want to send out something. Then the actual network is mostly just a virtual class. It has a couple things. There's some global things like a debug number, and then it has a object number. The object number is set to -9,000 because it should be set to 38, depending on if it's set up as a client or server. So if it's not set up as either of those and that number is wrong in the negative, that's just an easy way for me to know that it was set up incorrectly. I just have an enum for different player types and different network types. Then I have my input and output queues in the network, and then it also has the server port and the network type. And those are the only things in the network. Everything else is, you create it, nothing happens. The physics update does nothing. Neither does the cleanup. Neither does swap. It just returns nothing. Most of these, except for all the creating of packages, are just going to be virtual functions. Are all overloaded, rather, if you're in the server or the client, because they have different things to do in server or client. So the easiest way for me to do that was to just make all virtual functions and be it rather a server or a client. Obviously, if you want to create missiles or set object locations, the network needs to know how to do that, so the network will create these objects and put them into the input or output queue, respectively, and where they need to go. Stuff like that. So then in the server, obviously you have your server set up when you create a server. Then you have your physics update, which actually updates. Cleanup is just a shutdown. Swap turns you into a client instead of a server. And then connect, basically, if you're the server and you call connect, it'll just tell you if you don't have any connections, or if you have connections, which ones are available. So if you're in the main menu, hit C, it basically just tells you what's connected to you and what's not, or if nothing is. Read out is if you're the server, what packages from the output queue need to be sent to the client and what needs to be looped back to me. So everything gets looped back, so everything just goes to the input and queue. And then if it's a mine package or a set object position or create a missile, if two things collided, or if it's because somebody wants to start the game, then those things get sent out into the network to the clients. Then on the read-in, these are exactly the same for the server and client, except for this last one, which is just the delivery request on the client instead of delivery request. It's delivery response, because obviously the client doesn't need to request. Same thing on the client for the readout. The readout is just going to be, say if it's a move rotate player package, or create a missile, or create a mine, or start the game, then send it to the client because they want to know about it. And also if it's a create mine or create a missile, then I also need to know about it, because those objects need to be made for the client as well, so that when they come back with a move position, it knows what that object is. Connect is just going to say if you have a connection or not, if you call it outside of the beginning boot up. Otherwise, if you call it outside the beginning boot up and there's a server, it will connect to that server, but otherwise it won't switch it into a server. So then the only other thing on these is the There we go, the data. So when the data comes in, this is the same on both, but basically I create a package. Package is just a class I created to make it easier for me to understand what what the information actually is. So I create packages out of the packets that get sent over the network. So when I create a package, I basically say create a temporary package, and then I have a read network package function, which will call this function here. So it's going to go into my package. So package is a class here, is a virtual execute, it's a virtual load network package, and then it has a read network package. When you read network package, it basically goes in, it's going to read the debug number, and then it's going to read what kind of package it is, and once it figures out what kind of package it is, it will then use a switch to create that type of package. So let's say it's a mine package, it'll go here, and it's going to create a mine. So it'll basically then read the rest of the in message and load that information into that package, and it'll return that package. Then on that server side or client side is the same, it'll just enqueue that package so that when you call read execute on it, it will go through all of the input queue and it will just call execute on all those packages. All the packages here are basically the main thing that runs the whole thing. This is all of the data-driven part. So the data-driven stuff is all just these packages. They basically are created. The package itself kind of has a little bit of a header, so it always has a debug number and a package type. At the top, the debug number is set to the player local debug number. That debug number just goes up as you set things. Then the execute on takes a ship, both the ships, just because it's easier to access the ships that way for every movement than it is for looking for the object every time. Then it has a load network package, which will, on the base, it'll just load in the debug number and the type, because those are in the base. And then obviously we have this, which figures out what kind of package it is. So for all the other ones, we have a create mine, which just has the player number, mine ID, which is just the object ID, and then its position. So when you create it, sets it all up. Execute basically creates that mine. If it's a server, then it needs to tell the server like who created the mine, stuff like that. And if it's the client, it also needs to do that. So obviously for the server, it needs to tell the server where the object's created and who created it. And then it needs to create all the physics stuff for it. So if it's a server, it creates physics, the physics like body and all that stuff for it, because on this client, I don't need to do that. So in the client, I separated in the game objects the like what's created that's specific to the physics, and then what's not. So like on the missile, there's your create missile, which just sets up the owner's ID and then the max force. But if it's a physics missile for the server, then it also needs to call create missile physics and actually set up the physics data body, because the client doesn't need that, so why even bother making it? So obviously if it's the server, it needs a little bit more information, and then on the client, it just needs to tell that player that it actually used a missile, so that you can't use too many missiles. And then obviously we just have our load network packet, which will just write all that out and then read it in for the create mine package. Missile package is the same thing, just has the missile ID, and then if it's a server, it creates all that stuff and sets up that server, or sets up that missile with the same ID. So basically, whenever you create a package, you give it an ID. It basically just goes to that global number that I have for the object numbers, and it takes that number and then increments that number so that the number is always different, and then it has a unique ID. Then when the package is read, it uses that ID. So that ID is the same on both the server and the client, and if the server makes it, then it's like 38 or 39 and goes up from there, and then if the client makes it, it's like 9,000 plus. So it'll start at 9,000, 9,001, just so you can differentiate between what's the server, what's the client, and because then they won't overlap, because you're not going to make 9,000 different objects throughout the lifespan of the game. Move rotate player package is just the one that has the rotation and like W force for if you want to move something. And then the set object package, this is for missiles and the player's ships, because this sets their position. It just searches the list based on the object ID, and it finds it and it sets that position. And then the onHit package basically is the ID of the two objects that collided. Then when you get to execute, it makes sure that those objects actually do still exist, because if they don't, you can't call collision between them. And if they do exist, then you call collision between them, and locally on the client or the server, it'll do the particle effects and all that kind of stuff that it needs to do along with removing that object. And then start game is just the one that when you hit spacebar in the load menu, it will send a package to tell it like, hey, I'm ready, just let me know when you are, and the other one will hit space, it'll send back to the other one, I'm ready to, and if they both are ready, then they will both start. So that's the main stuff. The main stuff that was added was this network manager, the network itself, which is just the overridden stuff, the packages, which I have the 5 of, and then your server and client stuff. Obviously there were changes in the game objects as well. For mostly it was separating the physics from the rest of it, as well as some minor adjustments here and there between like what needs to actually be changed and what doesn't. These were for something I was trying before for collision that I ended up getting rid of. And yeah, that's about it in the game manager. When everything is loaded, I auto set all of the IDs for all of this stuff, just 1 through 36, to make sure that they're the same on the client and the server. So 38 if you include player 1 and player 2. So there's no issues with the differentiating between the two on those because they are all in both, so why not just put in the same number right off the bat. But otherwise, for everything else, it is good. Everything works. I can play through it a little bit here just to show. So obviously, like I said, you hit spacebar and both and it loads. Obviously, so whenever I move the keys, it sends a package for the key presses, and then it sends another package for where the position is specifically. So the client's just getting position packages, and if you're moving on the client, then it's sending movement packages, and then it's also getting in position packages for mines and stuff like that. It just creates the one package and sets a position, and then the server or the client does everything else itself. And then for mines, obviously I create them, and then it sets those positions once the position data comes in. So yeah, everything works, and it loops through multiple times, as you can see in the other video if you want to watch it, where it also shows that we're working on different computers, just to show that I actually got that working. So yeah, that's about it.